This is problem number 48, and I'd say it's a fairly challenging problem. It's an expected value problem. We know that because we're asked to calculate the mean. It is a deductible problem. We give it a deductible, and it is a calculus problem, and the calculus is challenging. You've got to set up the problem correctly and then do your integral correctly. So let's have a look. The first thing we're going to do is we're going to take this constant value that we're given, and we're going to use the stow feature of our calculator to save that as the letter T. You could use any letter you want. I'm just not going to use the letter X because we've already got an X in our problem. So we stow this constant as T just to clean things up a little bit. And the other important part of understanding this problem and deductible problems in general is that the amount of loss that is eliminated by the deductible, and it says the mean of the manufacturer's annual loss not paid by the insurance policy. So the loss not paid is the loss eliminated by the deductible. That's going to come in two parts. There's if the loss falls below the deductible, and that looks like this. We're going to pay some unknown amount times the probability that our loss is between 0.6 and our deductible 2. And I get to write my expression with T over x to the negative 3.5 dx. Amount that's paid times the probability that loss is between 0.6 and the deductible, plus, and this is the second part, amount that is paid times the probability that our loss is above the deductible, between 2 and infinity. So we know if the loss is 3, 4, 5, 10, 20, 30, we're only going to pay 2. There's a very well-laid trap in this problem if you don't recognize that the loss eliminated is going to come in two parts. You might fall for answer choice D if you miss that piece right there. So let's continue. The probability that loss is between 2 and infinity will be T over x. Oops, that should not be negative. I will come back to that in just a moment. Just 3.5. Okay. So let's simplify a little bit more. We have x over x to the 3.5. And then I don't like having my variable in the denominator. I want the variable up in the numerator. So that's why I had the negative there by mistake. I was thinking ahead. So I'm going to rewrite this with negative exponents. And in fact, I think I'll pull my constants out as well. So there's cancellation here. Pull the constant out front. And rewrite with negative exponents. So it's nice, clean, simple, only one thing to do inside that integral. Same thing here, pull the constant out. This time there's nothing to cancel with like there was here, but we can still write this with a negative exponent. So very, very straightforward, clean and simple. Let's evaluate our integrals one at a time. Here we'll have t times x to the negative 1.5, applying the power rule here, over negative 1.5, evaluated from 0.6 to 2, plus 2t times x to the negative 2.5, over negative 2.5, evaluated from 2 to infinity. Let's handle the constants and then do the substitutions. So going back to the calculator, we do t, which we stowed away here, divided by negative 1.5 to get about negative 0.46476 times, now evaluate the integral, 2 to the negative 1.5 minus 0.6 to the negative 1.5. There's the first piece. This is our average loss for when loss is between 0.6 and 2 underneath the deductible, plus 2t divided by negative 2.5, so 2 times our stowed value, divided by negative 2.5 is about negative 0.55771 times, evaluate the integral, infinity to the negative 2.5, stay with me, I will explain that in just a moment, minus 2 to the negative 2.5. Now, suppose for a moment, let's just look at this. We have infinity to the negative 2.5. Well, we could rewrite that as 1 over infinity to the 2.5 because that negative exponent says we can just take the reciprocal. And then infinity to the 2.5 power is still just infinity. And if you take the number 1 and you divide it up into an infinite number of parts, each of those parts will be infinitesimally small, and they might as well be equal to 0. So this is not, strictly speaking, mathematically accurate, but I think the logic follows well enough to understand that this term is just going to go away. Okay, we've got everything we need. So we go to the calculator and we evaluate this first piece to get 0.8357 plus, we evaluate this piece, just multiplying negative 0.55771 times negative 2 to the negative 2.5, and we get 0.0986. Add those together for 0.934, which is closest to answer choice C. So, challenging problem. The calculus, I think the real issue with this one is just setting it up correctly from the get-go and understanding that the loss eliminated, that the annual loss not paid by the insurer is going to come in 2 parts. The amount we pay, which we don't know when the loss is underneath the deductible, times the amount we pay, which we do know when the loss is above the deductible.